Hello everyone, it's June 12th, Saturday. It's gonna be a tough day. I have already foreseen it. But we're gonna do it nonetheless. Oh, plus, I just flossed today. My first floss ever. Well, I never flossed in my past 30 years of life. But today I flossed. It took me like 20 minutes to floss, while my girlfriend can do it in 1 minute. But hey, it's a skill. You need to practice. If I floss more, I can get better at it. Just like wearing contact lens. Took me also half an hour to put on my contact lens the first time. The same thing. All right, let's take a look. What we have today. Minimum number of refilling stops. A car travels from the starting position to a destination which is target miles east of the starting position. Along the way, there are gas stations. Each station I represents a gas station that is station I 0 miles east of the starting position and has station I 1 liters of gas. The car starts with an infinite tank of gas, which initially has start fuel, liters of fuel in it. It uses 1 liter of gas per 1 mile that it drives. When the car reaches a gas station, it may stop and refuel, transferring all the gas from the station into the car. What is the least number of refilling stops the car must make in order to reach its destination? If it cannot reach the destination, return -1. Note that if the car reaches the gas station with 0 fuel left, the car can still refuel there. If the car reaches the destination with 0 fuel left, it is still considered to have arrived. Alright, target 1, fuel 1, there's no gas station we can reach without refueling. Okay. Target is, what is target? Miles. Start fuel is 1. Station, we have 10 miles away. We'll have 100 gallon, but we cannot make it to the first gas station because it's 10 miles away. So target 10, start fuel is 10, and a station. Okay. What do we want? We want the least number of refueling, or the least number. We drive to position 10, expending 10 liters of fuel. We refuel from 0 to 60, and then we can drive to 30, right? Wait, now we drive from position 10 to position 60. Oh, we can drive directly to 60, yes, because that's only 50 in between. Refuel from 10 liters to 50, yeah. Then we drive to and reach the target. We made 2 fueling stops along the way, so return 2. Okay. The target, start fuel, 10 to the 9. That's fine, that's not an issue. Station length is 500. And the station, that's the position, right? That's the position. So station's only 500. So we can definitely do even worse than ON squared, where N is the length of the stations. Okay, dynamic programming. I mean, because you're asking for the least number, right? So let's see. At each station, we either stop or we do not stop, right? So there are 2 possibilities. So if I stop at a station, so if I have a station here, if I stop at a station, then I get all this gas. What do we want to do? I mean, the minimum number of stops, what does that translate into? It's not the maximum distance I can get, right? So no, so it's like when I stop at a station, what is the minimum number of stops I need to do before I stop here? right? What is the minimum number I need to do before I stop here? So we have the target, right? A target is here, and then from each station I have the gas, right? And then if we have a station that is, and that's possible. Hold on. Minimum stops. So we say from this station. So I want to use this as an example. So we have 10 miles, can add 60. 20 miles, I can add 30. 30 miles, I can add 30. And 40 miles, no, that's 60 miles. 60 miles, I can add 40. And the target is at here, 100 miles, right? So for each stop, say at 60 miles away and 40 miles, what is the minimum number of fuel that's needed to go from there directly towards the destination? So for 60-40, we can do 0, right? The minimum is 0. So as long as you reach here, you can get to the end. For 30 and 30, we have 70 miles, right? Minus 30 miles you can get from the gas. So we need to be at least larger or equal to 40, right? So for 20, it's going to be larger than equal to 50. For 10, it's going to be larger or equal to 10, we have 90, but we can get 60, right? We can get 60. So 30. So 30. So if I have 30 gallons, not gallons, I think it's liters. If I have 30 liters of gas in here, we're going to do 10 miles, and then we have 30 when we reach here, we get 60, we can directly go, right? So that's from each, so that's one stop, right? That's one stop. Then we just see if the car can do that. And then, okay, so that's the amount we need to have from a certain station to go directly to the end. So, because eventually we will definitely, right, we'll definitely have to hit some gas stations. And then from that gas station, we go to the end, right? So we have the minimum required to go to the end. So we start with a tank of 10, right? Start with a tank of 10. And also, in the start, if we do 0 stop, we need larger than 100. So we see, okay, it's not larger than 100, so we must refill. So we check the first gas station, right? If we go to the first gas station, we will have 0 fuel. Then we cannot. So if we do not have any gas left, so we just see the furthest we can go, right? The furthest we can go, and we loop through those gas stations. We check when we reach there how much gas we have left, right? And then from each one, isn't this like it's like a BFS, a breadth first search, right? Because initially you have a certain distance you can go, and then you can reach certain levels, right? And then you get there, right? You get there, then what? You get there, that's like the first node you reach. I can reach 10, that's like I reach 20, I reach 30, and once I reach there, I regroup, I refuel, right? I refuel, and then I have a new start from there to see where the next one I can get. And then we just say when we can get to the end first. I think that's just a BFS, a very well-dressed BFS, right? How do we implement this? Like just like how do we know which one we can hit? Right? So once we refuel, right? Once we refuel, and then like once we refuel, and then I have a new range, right? I have a new range, and then I can hit. Are there like a repeated computation? I mean, when I first reach and I have some fuel left, yeah. So at each node, right? At each node, I have at each node, I will have the amount of fuel left, and that is the key. So if in the future I reach a node with the same amount of fuel, so I don't have to do it again, right? So I can remember that. Say we already done it, right? So we don't push it into the queue anymore. But we will hit like here, I will end up this. So that's the only node we can get to. So we get here, we refill, so we got 60. Now we have 60, so we can hit this one, we can hit this one, and we can hit this one, right? So we hit this one, 60, we hit here, which result in 50. We have 50 left, right? We have 50 left. And we can do 50 plus 30, and then we can reach the end. And that's 2 steps. It's the exact same thing. Right? We can do here, so we can push this. Yeah, so we push this into the queue, push this into the queue, push this into the queue. Right? And actually, I'm going to push this node. Yeah, we push this node, and the amount of fuel will reach there into the queue. And the value is to 10 to the 9th, so it's hold up, 1 is 10 to the 9th. 0 is target, so it can still be big, so no. It has to be the key. Well, if we do BFS, but we still need to push like which one we have done. It has to be a tuple then. I have to push a tuple into a set. So next time if I same thing and we don't do it again. Right? So we push this in and we can push this in and we can push this in. And then this one pop out. When this one pop out, what we have is 50 liters left, and we have 30, and then we say we have 80, right? We have 80, and we say, can we reach the end? If we can reach the end, boom, we're done. If we cannot, then we say we have 80 in range, which means we can do 80 minus 20, we can do 60. We have 60 range, actually, 60 range. So we need to go 60 in range. Okay, keep going, see which one we can incorporate. Well, can we make this path faster? I mean, let's just say, to make this part faster, if we have to loop every single one, I feel like that's going to be slow. But if we don't loop through every single one, how do I know which one I can get? I mean, I say I have 60 range, or let's say I can do 80, right? I can do let's not say I can do 80. I have 50 plus 30. I can from 20, right? From 20, I can do 80 more miles, which means my range is 80 plus 20. We can reach 100, right? We can reach 100. So any node that's within 100 can be reached. So we have to loop through anyway. So we have to loop through. Every time I loop through, that's O(n) squared. And whenever we hit the target, then that is the end. Let's try to code it up. I think this is the correct way forward. Not 100% sure, but I'm pretty confident. So let's take a look at our BFS skill. Okay, let's do this. Where is code is here. If this is just BFS, I think this is not a hard question. It's just a medium question. Okay, so what do we do? We need, it's a BFS, so we need a Q, right? So a Q gonna be the, what is the, what do we want? What do we want? We want, we can do index, right? So what we want is, I don't know. I'm pretty sure these values are unique, right? The distance, they didn't say, but I think the miles east of the starting position, I think this value is unique. Because otherwise you'll have two gas stations at the same place. I don't know. Let's give it a shot. I'm not sure if it's. Let's use the test case. No, not this one. Let's use this one. 10, 10, 10, and 110, right? Hold on. 110, right? And then we say the same. It should not matter. It should not matter. So if it does not matter, that's fine. Index, yeah, we're gonna do index, right? We're gonna do index. So what's gonna pop out from the queue? It's gonna be current fuel, right, and the distance that I have. So the current fuel and at which gas station I'm at, right? So indices. So I say the Q is going to be indices. I'm going to start from -1 and with target number of fuel, not target, start fuel, and we have visited. Visited is going to be a set, but we don't have to put anything in it. Then we say while Q, right? While Q, and temp, that's the next level, for index for I, and current fuel in Q, right? Now, current fuel in Q from hold on, so we have the index having the current fuel, so we can say how far I can go, right? How far I can go. So my range is going to be current fuel plus stations I my range is current fuel plus station I 0 1, that's the amount I can get, then plus stations I 0, right? So this is the actual number of range I can get, like the furthest I can reach, right? The furthest I can reach. But of course, we have an issue here because I use -1, therefore it has to be a little bit complication, which is it can be this, right? If I is larger or equal to 0, else 0, right? So we're gonna be very explicit. So this is the range. If I is -1, then we're just gonna be 0. So just the current fuel, that's the range. Now is the thing. We need to see how far we can go. So I say for J, range, I plus 1, right? Have to be the next one, all the way to, we're going to use this a lot, so we're going to say N equals land stations. So it can be from here to N, right? When it goes through every one of them, when you say if stations, right? J 0, that is the range. Actually, on here, we need to also have a value called steps, right? Steps. Yeah, let's do this. Yeah, that's fine. Let's just say steps equals 0, right? 0 step. 0 step. Actually, it's not 0 step. I think the steps -1. Right? And then if the steps is -1, and then we come in while Q, for this, right? So the range, if range is larger or equal to target, then we're going to return the steps +1. So the next step, we can get it, right? Otherwise, for J, if this one is larger or equal to range, no, its range is larger or equal to this. If range is larger or equal to this, then we can say visited. Hold on. I think I don't like this. I want it to, for each node that I visit, I push into the visit, right? So for this, I say if I current fuel in visited continue, right? Else I say visited dot add I current fuel, and then I do the range thing, right? I do the range thing. Say range equals this, and when I come out, if I hold up. How do we know we get to the end? So I is this. So like if I can reach to the end, what's going to happen? Right? If range is larger than this. No, I think it's here. It is here. right? So a range is going to be from current fuel plus, yeah, I think it's true. Continue. And then we go to the next one, visit, then add this, and then range is from current to the end. Let's say if the range is larger or equal to target, then I just return, right? We're done. We know from currently, we add one more step, we're done. Otherwise, we're gonna go from here to the end, try every single one. If range is larger to this, right? If range is larger to this, then we add it. Then we say temp, right? Then we say temp dot append append what? When append j and the fuel that we're gonna reach there. So the fuel we're gonna have when we reach there is going to be current fuel, right? Plus current fuel plus, hold up. Oh. First one is still problematic. If my current I is smaller than just current fuel, shouldn't be range minus, yeah, it should be range minus my current fuel. That is, yeah, I think it's range minus current fuel, right? Range minus current fuel. Hold on. Current fuel, right? I plus the gas. And then I plus a current position. That gives me the longest range we can go. And I say now we can reach station J, right? So what we need to know is the difference between station J and my current station, right? My current station. So the difference and my current fuel minus this difference. So it's gonna be my current fuel minus the difference of from stations I 0 minus J0, right? My J0 minus stations I0. All right, so that's the distance I need to cover, which is going to take out from my current fuel. Current fuel, right? Current fuel. Hold on. So we have the current fuel, and then we reach the current station I, right? We're at current station I, and then we need to add the fuel and then determine where can we go. So we have to add, I think, we have to add the station I1. So this is range. Range minus this distance. Yes, I think it's just range. Range minus station J0, that's the distance, right? Range minus the distance. So we're going to append range minus, this is the fuel we're going to leave when we reach station J, right? We're going to append this and larger equal to this, and once it's not, we can break. I also going to break, right? Because if we cannot reach a certain destination, we cannot. Okay, let's see. Can we do it like this way? Probably we can. Yeah, it's all right. So we just go to the end. Right, we just go to the end. Doesn't matter. So go to the end. This will give us our temp, and then Once we get it, we say steps plus equal 1, because we're going to move on to the next queue, and we're going to say queue equals 10. And then we go back. No, this can be here. So I have to go through every queue, every one in the queue, we add new thing to the temp, right? We add a new thing to the temp, and then actually, I don't like this way. I want to check so I don't have to go through. Yeah, I like to check it here. That's the same. So we fill up the temp, right? We fill up the temp every time when we find one that we can go, and then we get out, queue equals temp, going back up, temp, and now we go to queue. If it's in visited, that means we've done it before, and we don't do it again. If not, we add, say visited, and then we keep going, and then whenever we hit it, we're gonna return, right? So what if we don't hit, like none of the targets, the target is not, and then everything, we never hit the target, then we keep going, and then we just don't hit anything. Then we're going to return -1, right? So let's do the test case. All right, first test case, 1, 1, empty. This is going to give us 0, right? Huh. All right, next one, 100, 1, and then we have 10, 100. This is going to give us -1. Cannot reach. Next one is 100, 10, and we have 10, 60, right? 20, 30, 60, 40. And this one will give us, I think, 6, 2. So this 2. All right, 3 test cases. All right, let's take a look. So we have target, start fuel, stations. And this is going to be min, refuel stops, target, station, no, start, fuel stations. Run it. Invalid syntax, because I forgot to add a comma. Let's get it larger. Run again. Oh, it would pass. Okay. Any strange test case? This one is a strange case because it's swapped. How about I do this? That's also a strange test case. We have repeats. We pass. How about we have cannot reach? Cannot reach. Oh, this one still can reach. Still 10. Oh yeah, let's do everything is the same. And we have different. That would be interesting. That should be -1. Hey, that's still 2. Oh, because of 60. Oh, wait. Why is this one still good? Oh, we're saying that we're ending in here, and all of these are within reach. Oh yeah, this means all. Yeah, and yes, I know what this one is. Okay, everyone is within reach. Okay, so this is not the test case. All right, let's try it. Let's try it. Submit. Pending. Judging. Taking a long time. Either wrong answer or we time out. We timed out. Fine. So the logic is correct, but we timed out. So TLE. All right. I mean, we already used this, but it's not enough. Not sure. I mean, it looks like it's all sorted. So one thing we can do is else break, right? Let's try this. If we break early. Nah, and still timeout. It still times out. All right. Now I see why this is not an easy question. Current fuel, when we reach a position, let's change it one more time. Let's see, we can do, what can we do? All right, when it's sorted, just in case, right, when it's sorted, so we're gonna say station.sort. I want to sort it just to make sure we can say else break, right? Sure that we can break. And then, instead of this, we're going to prevent it from getting pushed in the first place, in the first place, right? So it's actually just this sentence. For j in this, if is larger and this is not in visited, then I say visited dot add I current fuel and then temp. No. Add this, right? So this guarantees that the queue will be small in size every single time. Oh, the last one failed. Oh, the sort. Wait, what? It's not about the sort. Why did the last one fail? Let's see, if it's larger, then we do this, that's no problems. And then we go from everybody in it. Should only be like 500, right? And we still time out. So visited dot add. Oh, it's not. It's this. I'm gonna say for j in this remain fuel equals, so right, this is the remain fuel. The main fuel is this, and yeah, this one is, oh no, this one's not right. This is gonna be j, and the remain fuel is not in it, so we just do j and remain fuel. There we go. Now we pass. I mean, we can even try this test case, see how long it takes. I mean, this is not some large input. Yeah, it's not large input at all. Then we can just do this, right? So we say this and this, no, and the remaining. Right, it's not too big. We run it, not enough value unpack because we don't know the result. Let's try run it here. There's none optimized code. Oh wow, time limit. Hold up, that's just, I want to know the result. What's the answer? 20. So result is 20, right? And we run it. Damn, it does take a long time. Oh, wow. How? I mean, I just visit many times. Okay, okay, we need to optimize this. All right. There are places we can optimize, right? So when we reach a node and we say we can get to the next node, right? Um, let me stop it. Oh, 50. Take 50 seconds to run. No, that's not gonna work. So from a current node, I know how far, but what I say is we have to iterate through. If we don't iterate through, how do we know which ones we can get to? Well, we actually do. We can do binary search, right? So we know which ones we will get to. That's fine, right? But we still have to iterate through all of them. So there's no savings there because we already said we're going to break here. So there's no savings. That's not the saving. The savings is going to be this. How do we put the values inside the visitor? It cannot be remaining fuel, right? Because I think multiple remaining fuels will lead to the same result. See, I'm reaching at a gas station, right? I'm at this gas station with a certain amount of fuel, right? I'm at this gas station with, this gas station can take me to 70, right? Can take me to 70, which means this gas station can take me to here, right? Which means whatever gas I have here, that's gonna be the same, right? It's gonna be the same. Yeah, it's gonna be the same. So when I reach this, like no matter what gas station, what fuel I have, it's gonna be the same. But if I'm reaching here, right, then the maximum I can go is 50. So it's here, right? It's 50. So that means if I have more gas, say I have 10 gallons of gas, then but if I have less than 10, so 5 gallons of gas when we reach here, or we have 4 gallons of gas when we reach here, the result is the same. So that is the optimization. The result is the same. How do we do this? Well, when we have the thing, right, we need to know when we reach a gas station, right, when we reach a gas station, so the first one, when we reach a gas station, and then and reach the, say the first one again, no, we reach there, reach here, right? And then that's first round. The second round, from each gas station, we can reach further, and I can reach here again. Now the thing is these two reach resulting in the same scenario? Well, in order to find out, when we reach a gas station, right? When we reach a gas station, we now currently just say if I can reach it. If I can reach it, I actually need to also see how far I can reach it. What does that mean? That means when I reach a gas station, I have a certain amount of fuel, right? That means from this gas station I can go to a certain number of following. right? And then if another situation reach the gas station, then with a certain amount of fuel, I can go to the following as well. But my thing is, well, these two visits, if I can go to the same next gas stations, would that be the same? That actually it might not be the same. I'm pretty sure that when I run this, if I do hold up. This one is actually not right. If it's a larger than, we're gonna check this one again here. If it's not in, and then we can else then print dupe. We do. Oh, we do have lots of dupe. Oh wow, we do have lots of dupe. So we already handled a lot of duplication, but it's still slow. If I reach here with 5 gallons, right? But with 5 or 4 gallons, it does mean we can reach the same one, right? The result is the same, but when we reach here, the amount of fuel is different. We have lots and lots of duplications. So we already skipped. But it still takes so long to run. Would greedy work in this situation? I can see that greedy does not work if we go the furthest. What if like a DFS with greedy? We go with furthest first. If that doesn't work, we go the second. But then you're guessing, right? You're guessing. Hold up. Am I guessing? If I go to the furthest, right, from each gas station, I go the furthest. Not the further, we go to the gas station that the furthest away that we can reach. And from here, we keep going. And if we can hit the end, that's it. If we cannot hit the end, right, then we, like say from this, we go here, we fail, then we step back, try it again. If we fail again, we step back until we go through every options and they all fail, right? Then we go back one. Will that work? Not sure if that's gonna work, but wait, are you still going? It's using a lot. I think it's still going. The print takes a lot of time. I'm gonna cancel it. Quit. Alright, open again. Yeah, definitely do not print anything. So this TLE, so what I have is another idea, like a BFS idea, but with greedy in mind. give it a shot. So this is naive, BFS, and with TLE. I don't understand. Why would we TLE, right? Like, okay, I'm gonna do this again. That's gonna be stupid, but I want to try. So I'm gonna print again. I'm gonna print length of temp. Right? I'm gonna print length of temp. Let's see. Oh, it's not printing anything. Let's use a easier solution thing. 1 and 2, right? Oh, I think it's saying because our starting fuel is quite large, right? So starting fuel, so for each one of these, and then I am adding, yeah, why won't you print out? I mean, there's not that much you can, 53, right? It's not printing anything. Why? That's just one fuel. It's the start fuel. And we can get the range. I need to, yeah. I think that's fine. I dump it in. But when I cut it myself, I cut the spine. So we go from every single one, and then if it's good, and if this is larger than this, yeah, and if it's not invisible, I put it in, I put in temp. So I go through, there's only 500 of them. Why would it take so long to print out 500 of them, and then Q is only this much? So why does it take so long? It doesn't print out anything. Oh, I think it doesn't print out until the program finishes. That is stupid. Why would you do something like that? Hold up. I'm gonna make some changes. Just want to see, right? If I do this, yeah, it does print out, but it will have to finish the entire thing before it prints out. It doesn't print out as it goes. Maybe that's just, maybe I can coax it into doing it. Okay. Yeah. Let's see if we can coax it. Oh wow, look at the Q size. Oh wow, it grows. Wait. Hold up. Why would it grow so, well, why would it grow longer than, oh yeah, it will. Hold. So the first round, we get 3, which means from the starting point, we can only reach 3. That's true, 1, 2, 3. And then from this point, we can reach more. Oh no, we reach this again. From here, reach this again. But each time, when we reach, the amount of fuel is different. But if I say, if a node has been visited before, but if the fuel is different, if the amount of fuel is different, that's a different situation, right? reach a node, and then we have the amount, and then it's let me think. The amount of fuel is different, but how different? The amount of fuel, like if the amount of fuel to reach here, say that's 10, right, then I cannot even reach the next one. But if the amount of fuel reaches 1,000, 10,000, I cannot reach this one either. That's true, I cannot reach this one either, right? I am at 25,000, right? This is the fuel. No, that's the distance. This is the fuel, right? So I have the minimum I can reach is, these two together is 46,000. So minimum I can reach is this one. I cannot reach this one. That means if I have a certain amount of fuel, right, and that will only support me to, like, I cannot reach this one. So I have a large range of fuel that can only support me to reach this one. Like if I cannot reach this one, I already don't do it. But yeah, I start from here with 53,000 and minus this much, we have 40 something thousand, right? And then we plus this, we got 60 something thousand. So we can, like, say, go in here, right? That's the first round. Like directly. Oh, hold on. We can go directly. So it's from here and then here, right? If we go directly to here, then I can reach even further. Right? I can reach even further. I can reach even further. But do I have to still go through every single one? Because the fuel amount is different. Oh, is that frozen? You cannot cut the frozen. You just put that directly in the oven. So I cannot reach, so from here, I can reach a certain point, right? I can reach a certain point with a different fuel. And how do we know if we need to continue? But it will be different, right? Say, I know previously at a certain node, the furthest I have gone. I have keep a list of all the next nodes that I will visit from this node. And then I come to this node again, and I see that the furthest node I can make is the same as the previous one, right? The furthest node I can make for each time I reach node, I know the furthest I can make. And then I always go the furthest. I always go. So for a node, it's the first time I visit, right? I take all the other nodes and I say I can reach this, this, and this. And next time, first time I come here, I say I can visit all this. Next time I come here, I say I can visit this, 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 and maybe something more, right? And what I'm saying is all the other nodes, since I have already visited, then I do not visit them again. Why is that? Because if I visited a node, so I'm going to visit it with a certain amount of fuel. Now I'm going to visit the same node, but with different amount of fuel. And the question is whether the difference in the fuel is going to make any difference, right? If the 2 times when I visit a node, the difference in the fuel is significant, right? If the difference in the fuel is significant, then that means I need to push the new node in as well. If the difference in the fuel is small, right? If the difference in the fuel is small, then I say, how do you determine on the difference in the fuel? Furthest I can reach. The furthest I can reach. So I'm at this node, and I know the furthest I can reach, right? And I do all my stuff. And then the next time I come to this node, and I also know the furthest I can reach. And the furthest I can reach is, if it's the same, that means these two situations are the same. If it's not the same, but I'm going to say the second time a little bit larger. Well, this is a little bit larger. It doesn't allow me to reach any more nodes. But that might allow me to reach more nodes when I go. I don't know. This is going to TLE anyway. Let me try some other methods. Yeah, I'm not sure. This one's weird. Certainly not sure. Yeah, let's see what's the longest it can go. Oh, haven't done it yet. So this, yeah, let's just keep it here. All right, let's try another method. Let's try the DFS with greedy, which means every single time we're gonna try to go as deep as possible, right? Every time we're gonna go deepest, deepest, deepest. If we succeeds, so every jump we take the deepest, then I think that is the fastest we can go. If we cannot hit, so from a node, from the last node, we go, and from any node, right? We try to go, and we cannot reach the next node, right? If we cannot reach the next node, then we fail. Then what do? So this node is failed, so we go back. So now we go back. We try to find a node that's a little bit smaller, right? A little bit smaller, and we try it again. And it still failed, a little bit smaller. So we're gonna go every single one on one of them, every single one. If none of them works, then we can step back, right? So basically we're saying we're gonna go through, so like from the first, from any nodes, we go to maximum, they go to the entire range of one node, right? Entire range that one node can go. If it fails, we go to the previous node, the entire range that node can go. If it can now go to the previous node, and the entire range that it can go. But still, I think this is gonna time out as well, because we still haven't solved the problem of how to the DP, right? Where does the DP come from? DP shall come from, if it's right, so like if I'm here, each node, right, each node we shall know, at each node, we shall know what is the range that I cannot keep going, right? So from here, if we reach with 0, so we know we can go 50, right? We can go 50. So that means from 0 to 9, right? From 0 to 9, it's a no-go. So any time if I hit here, it's a 0 to 9, then if it's 0 to 9, I can always hit here, right? So if I hit 0, I say I can go here. And this one, I say you can go here, right? And that would reach the end. But it is possible that it's not the maximum. It's not the minimum, right? I can see that we go the maximum jump, and then we jump also the maximum, and then we take, like, say, 3 steps to reach. But if we jump a little bit less, then we can take 1 step. Yeah, it's definitely possible. Say, initial start, like we say, we'll have a 5, right? Have a 5, 100. And then we say, when we go to the maximum, we take 2. But with a 5, we also take 2. 1, 1, 1, 2. No, take 5 is 1. And then that's it, right? So if we say we take 5, it's going to be 1. And that is something I don't think we can solve by, say, 110, right? Let's say we have a 5, 100. This shall take 1. 1 step, 1 fuel. Yeah, that should be 1 fuel. But if we do the so-called greedy DFS, that one's not going to work. Yeah, it's 1 fuel. So we fuel here, and that's it. But if we do greedy, we say we're going to go here, and go here, and then we always return the answer is 2. Maybe you should sort. I'm going to rethink this one. Does it calculate the result? Wow, it's still working on it. That's it. It looks to me exponential, but I don't know why. From each one, we add all of this. From each one, we add all of this. Each one, we add all this. Next round, from each one, we add all this. Yeah. I think this is... Yeah, it's just because this one is not working. The visited, the set thing is not working. Because I don't know what to put in there. We cannot say we just visit one and we don't visit again. Because with different fuel to go into one, the result will be different. There are 2 levels of things. I have different fuel options. And I was trying to say it could be different fuels, in a range of fuels. The result will be the same. But I mean, how do you know the result is the same? Let's try it again. Let's think about something else, like from bottom up, not bottom, from the reverse. We will have to go from certain position to the end, right? So we can search through ones, every single one. Let's say, can I reach here? Can I reach here? Can I reach here? And I say, nope, we cannot. But then, I can start from these positions. But this is the same as this one. say if I want to go to the end from here, right? The minimum steps to go to the end requiring this step, right? Because from this step, I can go to the end. So I can go to the end. So because I'm at 60, and I need 40, so from this step, we can go to the end. I can allow fuel to be 0, right? I can allow fuel to be 0. And then we can reach the end. We can reach the end with fuel 0. I want to see, so from where I can get to 60-40. So log front, can we get to 60-40 from the previous one? 30-30? Yeah, we can. 30-30 we can, so we can get. So if we have the minimum to reach 30-30, then we know 60-40 will be 30-30 plus 1 to reach 60-60, 60-40. Right? How about 20-30? Now 20-30 cannot reach with 0. So from 20-30, we need to have minimum fuel of 10, right? We have minimum fuel of 10, and then we can go from 20-30 to 60-40. How about 10-60? 10-60 we can, with minimum fuel larger or equal to 0, because from 10-60, I can reach 60-40. And then from the start, I need the minimum fuel of 60. Right? So from the perspective of 60-40, we say the minimum steps to reach the end will be the minimum of 30-30, right? Minimum of 30-30 with conditioning fuel is larger or equal to 0, or from 20-30 with condition fuel is larger or equal to 10, or with 10-60 conditioning fuel is larger or equal to 10, right? So we can take the minimum of these three, or the start with fuel is larger or equal to 60, right? The start will be 0. Like this one will be evaluated 0. So that's the conditions. So now we need to know from 30-30, right? What's the minimum of 30-30? So that's 60-40 with conditioning is fuel larger or equal to 0, right? Now from 30-30, hold up, let me get a new piece of paper. Right, so from perspective of 30-30, the minimum steps to reach 30-30, right? The minimum steps to reach 30-30, and with condition minimum steps to reach 30-30. Minimum steps to reach 30-30. What does that mean? Like, and from 30-30 to reach the end. So from 30-30 to reach the end, we need a fuel larger or equal to what? 40. So if it's larger or equal to 40, if I reach 30-30, larger or equal to 40, then from 30-30. Minimum steps to reach 30-30. Then from 60-40, I can go look at 30-30 to know the minimum steps. The minimum step to reach each one with a range. So that everyone has to have also have a range, right? I reach a station with a certain amount of fuel. The minimum steps to reach a station with different ranges of fuel. That's what it is about, right? Again, so let's say we start from 10, so from 1060 standpoint, right? Minimum to reach 1060 is when we reach 1060, there's only one possibility, right? So we'll have remaining zero fuel, right? With zero fuel. That's minimum step to reach 1060, okay? So minimum step to reach 2030, right? Minimum steps to reach 2030. And from 1060, if I want to reach the end, use the minimum, use the range, and we cannot reach the end. So the most we can do is to go to 70, right? We can go to 70. So to reach 10, 20, 30, right? We can reach 2030. So we can either go from the start, which we cannot go from the start. So we can go from 1060. If we go from 1060, then we check at 1060 what is the fuel range. The fuel range is 0. And we say 20, 30, if it's 0, then we can reach 2030 with we add 60, right? We add 60, and then to reach 2030, we'll have 40 left. So 40 fuel left when we reach 2030. That's the only possibility to reach 2030, have 40 fuel left. There's no other way, right? And from here, with 40 left, if we plus 30, that's 70. And then plus, so that's the fuel when you reach, right? And then plus 20, that's 90. So still it cannot go directly. So that's that. So minimum steps to reach 2030 is what, like 2, right? To reach this is 1. Oh, is that 0? Yeah, that's actually 0. So minimum steps to reach this is 0. Minimum step to reach this is 1. 1 step to reach 2030. Okay, that's it. That's all the analysis for 2030. Now we look at 30, 30, right? We look at 30, 30. No, it's actually 50. My bad, it's 50. Not 40, it's 50. Because we're already at 10, and then I can add 60. From 10 to 20 is only 10 miles difference. So when we reach 20, I'll have 50 left. And then 50 plus 30, and then we can actually reach. So this one will already reach the end. Right, so steps is 1. Right? But we can keep going. Let's say the minimum steps to reach 30, 30. The minimum step to reach 30, 30, I can try from the start. I can now go. I can try from 1060, right? 1060, I can reach 3030 with 40 left, right? With 40 left. And 40 left, that 40 plus 30 plus 30, that's 100. That's, again, it's a goal. Well, actually, it's two steps. It's not one, it's 2 steps. 2 steps, because this is also 2 steps. So we have go, so 2 steps. And we can also reach from 2030, right? From 2030 to reach 3030. Yeah, you can eat everything. Yeah, put it in the food processor. So from 2030 to reach 3030, we will have fuel is going to be let's slice. Now let's blend. Cut them into small chunks and blend. So from 2030 to reach 3030, then we will have a lot more of these distances, right? Yeah, we'll accumulate lots of distance, lots of fuels, like lots of fuels, and each one we have multiple fuels from each position. That's all the possibilities of fuels that each position can have. So when we iterate through, we not only have to iterate through all the previous not only is it all the previous, but also all the fuels that we can reach. Yeah, that's gonna add up. This means we can reach a certain gas station with like many different types of fuels, many different ranges of fuels, right? And then for the next one, I'm just gonna read through every single one of them, and then but I have to read through all of them. Like it's all of them, all possible. At a certain gas station, right? I have many different fuels left that I can reach this gas station, right? And then with each we have the minimum steps, and then from here I can check, right? I can check all of them to see if I can reach the end. If I cannot reach the end, then I go to the next one, and the next one I have to go through from the front, right? From the front, the guy that can actually do it to reach here, and then I'll have 1, 2, 3, 4 or whatever. But we can avoid some of them. Like if a certain fuel that does not support me to go even to the next one, then that's a dead end. Okay, so that is something we can filter, right? That's something we can filter. So we go through the gas station from the start, and we pick the largest fuel that's left and see if it can reach me. If it can, and I calculate how much remaining it would be, and I calculate how far it can go. If it cannot go to the next gas station, then I don't consider it. And I would keep going through all of them. Like if one of them already cannot support, me to go to the next one. Like if this is a dead end for me, then I do not continue. Then I move on to the next one, and again, I compute how much. So I have like a minimum, right? The minimum required for me to go to the next one. If the fuel left is smaller than the minimum, then I don't consider it. So I will only get the fuel that will allow me to at least move on to the next station. And of course, I'm going to start from the biggest, right? If the biggest, I can already reach the end, and that's it. If I cannot, then I will store the remaining fuel, right? I'll store the remaining fuel and keep going on until I reach a fuel level that doesn't allow me to go to the next one, right? So that will be just a certain amount, which is determined by the distance between me and the next one, right? So between me and the next one, I'll say I can support a certain amount. Like if it's the larger the equal to, right? So if I can go like from here, right? When we add this amount, I can already go to the next one. So everything works, right? And why is this? Like say from here to here, if I add this fuel, and it's you can include everything, like from here to here, we say it's 8,000, right? So it's 8,000. If I add it to it, that's 70 something. So we need a certain amount, right? So this one will serve as a filter. We'll filter out quite a lot. So when we reach this, right? And we always go from here, right? And whenever we, at a certain point, we cannot go, we have to go through every single one of them. Because it is likely that we have some large field ahead, but with a smaller, small at here. So we still go through every single one, and each one will go through a few, right? A few, from the largest to the smallest. If we can support, right? So like this one we can support. So from here, I can actually take it. I can take all of them because we can take 0. We can take all of them. But some, like say here, this one can only take very few, right? It can only take very few. So this one will have a small list. So we'll go here. From here will be a small list, and this one can reach here. So I can take everything from here. And we can take everything from here. Oh man. Let's try this idea. If this still doesn't work, then I'm gonna call it quits. Okay, so I think I need a priority queue because I'll always want to pop out the largest remaining fuel first. And whenever the largest remaining fuel, whenever the fuel that cannot support me, then I'm just done. So I'm gonna import heap. So what is the idea? The idea is for each, so I'm going to say DP is going to be a list, right? And then say for a station, I'm going to say for station going to be distance and fuel in stations. I distance fuel in enumerate the stations, right? So we enumerate the stations, and we say the minimum, right? And we can actually add the target at the end. We can actually add a target at the end. So we know the minimum. Actually, we don't have to. What if I reach the end? Well, we still need to know. So +1, right? Number of steps. It's not guaranteed. I have to go through every single one of them. Next is here. That can support me. If nothing can support me, then I cannot go from here. And then I reach the end, and I go through every single one to see which one the minimum steps I need to reach a certain minimum steps. Minimum steps to reach here with the fuel. Minimum step to reach here with the fuel. Minimum step to reach here with this fuel. Minimum steps to reach a certain minimum steps to reach a certain gas station with a certain amount of fuel. So for the last one, I'm just going to go through all of them. It'll be the minimum steps. So we go through each one and see what is the minimum to reach here, a certain fuel. So what's the data structure going to look like? So we have fuel is the key, is the tuple. Fuel is the key, and the minimum steps the second value, right? So we can always pop out the fuel, the largest fuel, and then we see if it can support me going at least to the next station. If I cannot go to the next station, then that's a no-go. So I say we're gonna do stations dot append target. I'm gonna append target and 0, right? I'm not gonna do anything. Then n equals len stations. Actually, I'm gonna do it here. N equals len stations. So we're gonna say for I, right, in range n. For I in range n, dist and fuel equals stations I, right? Then what we need to know is for each DP is going to be a queue, a priority queue, right? Then for this and fuel equals station I, Then we say, what do we say? We say if I is 0, right? If I is 0, that's the first case. Then we just need to check the start field, right? If I is 0, so we check the start. So everyone has to check the start field. Everyone has to check the start field, right? So we're gonna say dp.append this, all right? Then we say if the start field is larger or equal to distance, right? Larger or equal to distance, then dpi, I'm gonna say heap q.heap push dpi, I'm gonna push something into it. dpi is yeah, push something into it. What do we push? Well, we're gonna push the remaining fuel, which is the distance minus start fuel, and we're gonna take the negative of it. Right, I'm gonna take the negative of it. I'm gonna take the negative of this, and then what? Take the negative of this and the minimum steps. That's gonna be 0. Take 0 steps to reach here, right? So minimum steps, right? Else, so the start fuel is smaller, so we don't do the start fuel. And then we're gonna say for something inside the DP, right? So I'm gonna say for heap, all right? For heap in DP. Why always every time you type this, it gives you things. I don't want things. So for heap in the DP, right? That's just every single one of them, and if start fuel is larger, no, we're gonna say if we cannot reach to the next one, then there's no hope, right? And there's no hope. So we only store the value that at least allow us to reach to the next gas station. If I cannot go to the next gas station, what's the point, right? So just stop here, and we cannot go. So we say if fuel is larger or equal oh, where am I? Yeah, my point is it's if I cannot go to the next gas station, then there's no point. So it's not going to be start fuel is larger or equal to distance. It has to be larger or equal to distance, and I also need to know from me to my next gas station, what's the distance from me to my next gas station? And it's going to be the distance. So what is storing here is the remaining fuel, right? So the remaining fuel has to be the distance between the two gas stations, so it can reach me, right? And from me to the next one, and also, of course, plus the gas that I have. So that means if I can reach the next one, so if the start fuel, right, is larger equal to the distance, that means you can reach me. That's the first requirement. And the second requirement is if start fuel, so it's just like if the first requirement is the start fuel can reach me. The second requirement is if it reaches me, it must be able to support me to go to the next one. Otherwise, there's no point. There's no point. Right? It has to go to the next one. So we say fuel larger equal to distance. Start fuel is larger equal to the distance. Then I can reach me. And then from me, I say the remaining fuel is start fuel. So the remaining fuel is start fuel minus, this one is start fuel minus distance, right? And we say if remaining fuel plus fuel, right, plus my current fuel, and plus my current distance is larger or equal to stations I plus 1, 0. That means I can reach the next one. Then I say I push this. Otherwise, there's no point, right? The only point is if I can reach the next one. And then I say, and I push. This is just the remaining fuel, right? This is remaining fuel. So I push the remaining fuel and 0 step, right? Else, if I cannot go to the distance, if the start fuel does not allow me to go to my, then I'm going to check every single heap in the DP, right? And for each heap, I'm just going to do what? I'm going to pop it out. So we pop out as the largest fuel, and then what if you do it? You have to place it somewhere else. Yeah, we have the largest fuel, so I know. No, let's not do DP. It's just going to be a list, right? I just put all the fuels in a list. Doesn't really matter. Let's just put everything in a list. Let's just say DPI dot append remaining fuel and this. Well, we just put this in. That's fine. And then we're going to say for remain fuel, for each one we have the fuel, right? So it's the remain fuel. No, it's not. This is actually the starting fuel there, right? It's going to be the start fuel. Let's call it begin fuel. So this without confusing. So the begin fuel and mean step, right? And no. It's going to be for all the possibles, for all the states in this, and for this in states. Right, that's going to be for each one and for all these other states, the good state that each one can afford. And then I say, and also we need I. So I need to know which one it is. So no, that's not true. The I should be here for I. I will use I for J. States in enumerate DP. Right. So for each J, that is a station. So what we need to know is the beginning fuel that in that station, right? And the beginning fuel. But then we have a problem. Actually, it's no, this is too complicated. I don't think this is the right way. I'm giving up. I'm gonna check the answer. It's already an hour and 46 minutes. Probably, I don't think this is a hard question. I think it's just I got stuck. I think maybe it's a medium. If I can give some hints. All right, let's see. Oh, it is a hard question. Oh, it has solution. Dynamic programming. Priority queue. Simple code greedy. DP from ON space complexity. All right. Yeah, I know. It's like oh, this is a Google question. I'm gonna fail the Google. Somebody said it's a Google question. ON login. You can use priority queue to reach ON login. What the heck? Look, it's so simple. Okay. Well, the fastest location we can get to using I. The farthest location we can get to using I refueling stops. We want the smallest I for which DPI is larger or equal to target. Okay, let's digest this again. Determine DPI, the farthest location we can get to using I refueling stops. We want the smallest I such that DPI is larger than target. Correct. Let's update DP as we consider each station in order. We know stations, so we can get a maximum distance of start field with 0. Yeah. And now we say if we want 1. Okay, let's stop right here. Let's think about it. What is this? What the solution means? It says we want a DP table where DPI I is the number of stops. So I want to say DPI means the farthest we can get to using I stops. So we say we start from DP0. DP0 is 10, right? The farthest we can get. Now DP1, so 1 stop. So 1 stop, the farthest we can get from 1 stop is loop through everything and see where the start field can get to. And the start field can get to the first one, right? And from first one, the 1 stop. So, right, that's 1 stop. So the furthest we can get is 10 miles plus 60, 70. It's going to be 70. DP1 is going to be 70. Now DP2. DP2 is 2 stops. So we're going to go from this to the first one, and then from the first one we can go to here, we can go to here, or we can go to here. All right. So we know dp2. dp2 actually we already hit 100, so that's the end. So what if we know dpi? How do we compute dpi plus 1? That's a good question. We know dpi. How do we compute dpi plus 1? dpi is the farthest we can get to. So dpi plus 1, the farthest we can get to. dpi plus 1 is at 1 mole. Right? Which means if that's the farthest we can get to, so are you saying everything within the range we can get? Like how? Okay, I still don't know. So each station order with no station, yeah, that's fine. Okay, the update step. When adding a station, anytime we could reach this station with T refilling stops, we can now reach capacity further with T plus 1 refilling stop. Anytime we could reach this station with T refilling stops, we can reach this with T refilling stops. We can now reach capacity further with T plus 1 refilling stops. If we can reach a distance of 15 with 1 refilling stop, and now we added a station at location 10 with 30 liters of fuel. Okay, so we're saying if we can reach, the furthest we can reach with 1 stops is 15. And we have a refilling station within this range, within this 15 range, right? Then we say the furthest we can reach is what, 10 plus 30. Then we could potentially reach a distance of 45 with 2 refilling stops. Okay, this is the logic that I need to figure out. If we can reach a distance of 15 with 1 refilling stop, doesn't matter where the refilling stop is, but we know the maximum we can reach is 15. So if we do 1 refilling stop, we can definitely reach 10, right? We definitely can reach 10. And from 10, the minimum we can reach is 40. And the maximum we can reach is 5 plus 40, which is 45. That is true. Let's go back here. Think again. What is it trying to say? From each, so yeah, instead of thinking about the minimum of steps that I can get for each stop, we're thinking about, given number of stops, what is the furthest we can reach? And I say, if I have, given I steps, the furthest I can reach is S. Okay? And now I have a station with distance smaller than S. If the distance is larger than S, with I number of steps, I cannot reach that gas station. But if the gas station is smaller than S, then I can reach this gas station, right? Now, when I reach this gas station, because I know with I number of steps, the farthest I can go, which means I can go with fuel reach 0. The farthest I can go is S. But now the current step is less than S. That means we can use the farthest scheme to reach the current, gas station, and that means I can save S minus the current gas station's distance amount of fuel, and that amount of fuel can be added to the fuel supplied by the current gas station to reach the maximum distance I can reach with I plus 1 steps using the current gas station. And if I go through all the gas stations that are within S, then I will have the farthest I can go with I plus 1 steps. Ah. Wow. I admit defeat. This is, man. Hard questions always hit and miss. Like, when you read this, it's like, yeah, it makes sense, but it's just a way of thinking, right? The way of thinking, like my way of thinking, I'm like, oh, it's a graph, and then I'm just gonna do breadth first search. It definitely works, but the thing is, this thing doesn't hit very often, and then you see, like we hit all these, the Q length, right? The Q length just grows tremendously. It doesn't work. So we need to rethink. Yeah. DP is always about the right way to think about it. And if you don't think right, it's not gonna work. So this is, I wasn't able to solve it. This is from the official solution. It's a DP solution. The key trick is that we find the farthest one can go given I number of steps. Is that we find the farthest one can go with I number of steps. So this is the DP. This is the DP. Alright. The goal is to find the smallest I such that dpi is larger or equal to target. The update step is like this. Given dpi, to compute dpi plus 1, we go through all the stations whose distance is smaller or equal to dpi. Then we can compute the farthest each station can sustain by station station J, right? It's going to be station J by station J 1 fuel plus dpi, that's the maximum can go, minus station J 0, right? This is, we can do the farthest each station can sustain by this, and then dpi plus 1 is the max of all these values, all these farthest sustainable distances. Okay. dp is going to be equal to this, and we can actually compute dp0 is just the farthest we can go with the start fuel. So I can actually say if start fuel is smaller than stations 0, 0, then gonna return -1, right? Otherwise, DP gonna start with the stations the farthest I can go, so we can go from DP0 is going to be starting. No, the DP field is just DP0 going to be the start field. Start field. No, I don't think this is necessary. DP is just going to be this. This is starting, right? And then we're going to say for what? No, it's not for what. It's going to be while true. No, not is it while true? When is the thing end? Steps. Well, for I in range, len stations, right? That's actually we can do 1, 2, 3, and now station plus 1. I is the number of steps, right? The number of steps. And I say if dpi is larger or equal to target, immediately return I, right? If the entire thing we cannot return, we're going to return -1. Now we're going to build dpi plus 1, right? So what do we do with dpi plus 1? So we're going to say dpi plus 1 is going to be for distance and fuel in stations, right? If distance, actually no, if let's say the current station, if farthest each station can sustain, right? So yeah, so if the distance is smaller or equal to what? To the, actually it doesn't really matter, right? Because I have to do dpj minus this, and we want the maximum value. So I think I can say dp dot append the max value. I think it was dp dot append the max for this fuel in station, right? And then this is going to be fuel plus dpi minus distance. If dpi is smaller than distance, this is not going to be the max value. So we're just going to compute the max. And holy moly, that's it? You've got to be kidding me. Please don't. Let's try it. We have. Wait, where? No module named heap q. Oh, not even heap q. It's gonna be q. All right. It is almost done. For the last one, my answer is result is -1. And dp dot append the maximum dpi minus distance in fuel is the furthest we can go right? Furthest we can go, and then we take the maximum, and then we add to it, and then we go to the next one. Start with 0 and go to 1, and say dp1 is larger than I. Hold up, why the last one is not right? So what I'm afraid is, because I changed the last one, so I'm actually not sure. Let me double check. Let me double check the last one. Let's come back here. You know what? The best way to double check is just copy and paste this code, and then we run it to make sure, right? And copy this. Let's see. Did we got it wrong? Yep, we did got it wrong. Okay. Let's check the DP table. This is the DP table, and then we say nothing is larger than 1 million. Indeed, nobody is larger than 1 million. Alright, something is not right. Something is not right. The 0 step is the start of fuel, right? And then this is the 0 step, and we can go for at most n steps. This means n steps each one. We have to visit each single one, right? N steps. And for each one, we say dpi to be 0 if it's larger than target, then that's it. And then we try to add the next one. We say maximum fuel is a distance and fuel, right? In stations, like in all the stations. And now we say it's going to be the fuel that can sustain plus dpi is the maximum we can go. dpi is the maximum that we can go, right? And then dpi minus distance, right, is going to be the extra savings plus fuel. That's the extra fuel, right? The extra fuel, that's the extra fuel. We can go. The problem is the plus this, and that means if we plus this, doesn't that mean we no, it can be like this, right? Fuel plus dpi, because it could be dpi minus distance, right? That's the fuel savings, and I'm going to plus the fuel. That's the total fuel and the maximum chance, and I need to plus distance. That's the maximum distance I can reach, but I can only do this if dpi is larger or equal to the distance. Then we hit 19. The heck? How about everything else? And we have a max argument is empty sequence. Okay, don't panic. Do not panic. Hold up. If nobody, if nobody can go, well, we probably should not do it this way. Yeah, let's, because we can return -1 immediately, like for this, right? And max, or we can just say dp dot append what? -1. Now I just say max this equals -1, right? And I say for this, and if dpi is larger or equal to the distance, then we say max distance equals max distance fuel plus dpi, right? Actually, let's make it more explicit. Fuel plus dpi minus distance plus distance. Oh, yeah, that's just a comment. Fuel plus dpi minus this and then plus this. The max you can reach. Right? Once we go through all of them, we say if max distance is smaller than 0, that means we cannot go anywhere. Then we're going to return -1. Right? Else, if max is larger, then we say dp dot append actually we can just do don't append, we can just say 0 times, no, not just append, it's fine, dot append max distance. Okay, so we pass the other things, but we do not pass the last one because the answer is 20 and I am getting ridiculous. Why is that? Minimum steps is larger than the target, right? dp dot append the max distance, that's the distance that the next one can reach, is the fuel plus the largest in the previous one. And then the next one that's weird. What the heck? I thought I understood it. Well, this is actually, we're gonna say plus station J is 0. And this is the largest, all these are the sustainable distance, right? And then we still got it wrong. If dpi is larger, what is not 19? Alright, I need help. Like, what the hell? Okay. This does not look like how I write it. location capacity, if it's larger than location, oh, hold on. I know why. I know why. My bad. You cannot loop through the ones you haven't reached before. Dios mío. We're talking about at like how many steps? Like one step, right? Hold on. Why can I not? Why can I not loop through the entire stations? Of course you cannot loop through the entire stations because we're talking about I number of stations. We can only have one station, right? One station. Like, say, we're going to go from 0 station. 0 station is good, right? Next, we want to say what is 1 station. What's the further you can go with 1 station? Then we loop through every single one in it, and we say if it's larger than distance, then we can calculate. Then we have 1 station. Now we go 2 stations, right? 2 stations. We go 2 stations. That means we already hit 1 station. That means, hold up, that's still 2 stations. But we don't know which station we hit. We just know that the furthest that we can go with, say, 2 stations. And then, which one do you consider? Every single one? If it's every single one, then I think it's possible that some station gets counted twice. Right? Some station might get counted twice. That's not what we want. We don't want some station get counted twice. So say 2 stations. So we have 1 station, the furthest we can go, right? Then 2 stations. How do we know which one to take with 2 stations? Let's check again. That's DP, right? So we go for I and the location. We loop through each locations. And then we say, okay, I think this is slightly different. We just say from this station, the maximum, if this t is larger than location. It is different. It is different. So this is how you handle. So for our case, we loop through I is the number of stations, and then for each one we go through the entire thing. And this is problematic because we don't know which one we have taken already, so we run the risk of going through the same station multiple times. But that's not right. What should be done is you loop through the stations, and at each station, right, at any station, there's a possibility of going from 0, 1, 2, 3 until that station, that many stations, and we keep updating how many, the maximum distance we can reach, right? The maximum distance we can reach, like given my current station, right? All right, let's try it again. So if I'm at this station, I'm at I station, right? And then we have the DP. DP will be populated from 0 to I, right? We're talking about 0 to I. Then that's the largest that I can get from those steps. And then I can do I plus 1. All right, let's try it again. Let's try it again. So I'm going to say this plus 0 times length stations. All right, and then let's rewrite everything. All right, so what we're gonna have is for I, this fuel enumerate stations, right? And for each station, we can go from the DP to know, right? From DP to know the furthest for each step. So I'm gonna say for T, I guess using the notation for T in range, it is from I. Because actually we can go from to I, right? From range I. No, I plus 1. Let's see. This is the thing. Do we go from front to back, from the back to front? Well, that's an interesting question. So for each computation for the T, right, the T steps, so I know the furthest I can go. And then I need to compute T plus 1. That's fine, right? Hold up. So the DP table is currently the T step, the further I can go for T steps, right? And then I say I'm considering my current station. And then I go dpt, I'll give the furthest I can go, so I can compute dpt plus 1, right? Including my current one, so I can compute dpt plus 1. Oh, we are updating. We're updating from T. I can update T plus 1. And the T plus 1 is including my station. So this is a DP table, right? And then we know, say, 0 step was the furthest I can go. 1 step was the furthest I can go. Now I say, including my current, what is the 0 step furthest I can go? 0 steps is nothing you can do. So what is the 1 step the furthest I can go, right? What's the 1 step the furthest I can go, which is 0. We're going to include that, so we can compute that. And then we say 2 steps. What's the furthest I can go? Is going to be, we cannot do 1, right? Because if we do 1 again, then the current station might be considered twice. The current station can only be considered once. So we have to go from back to the front. Yeah, if we go front to the back, DP1 can use the current station. And then DP2, right, it's going to be DP1, that can use the current station again. So we have one station visited twice, right? That's not correct. So we go from back to the front. So we say DPT, or DPI, right? DPI, to compute DPI is actually computing, so it's actually DPI is the number of steps taken for I stations, which is currently is actually I plus 1 stations. So DPI, I can compute DPI plus 1, right? So DPI plus 1 will be including the current station, right? And then I compute DPI, which will not include DPI plus 1, because to compute DPI, I need DPI minus 1, and DPI minus 1 is not including DPI, is not including current station. That's why we have to go from bottom to the front. All right, this is actually very important. must go from back to front to avoid including the same station twice. Okay, so now we say from all right. So what we're saying is for t in this range, right? You can say dp t plus 1, right? T plus 1 is going to be equal to the maximum dp t plus 1, and it's going to be dpt plus fuel, right? We use the same idea as here. Now this is actually not right. We cannot go through all the stations. To update given dpi to compute dpi plus 1. So we have to, we have to iterate through all stations. For each station I, we update dp 0, no, dp 1 to dp I plus 1, dp 1 to dp I plus 1. By finding the max of dpi plus station, well, from I to 1 to, we update dpt where t ranges from 1 to I plus 1. Note that we must go from dp I, oh, it's hard to say, from dpi, I'm going to go from the end of, I'm going to go from, for each station I, we update dpt where t ranges from 1 to I plus 1. Note that we must go from dp I plus 1, right, back to dpi and dp1, because the update logic is dp t plus 1 equals max dp t plus 1 and dpt plus station I plus station, no, dpt minus station I, distance 0 plus station I 1, that's the distance, m plus station I 0, right, which is equal to max dp t plus 1 and dpt plus station I 1 is equal to this, right? This means if we go from dp1 to dpi plus 1, then stations I might be used in 2 separate dp I might be used in might be duplicated, might be used twice. Yeah. Might be used twice. Might be used more than once in computing a dpt value. Yeah, that's the logic. That's why it failed, because some going to use it twice. So for t in this range, so dpt plus 1, then equal to maximum dpt plus 1, and then dpt plus fuel, right? So once we're done, and that's it. That's what we build a dp table. And then we just need to find, so when you say for j, for I, max this in enumerate dp, return I, no, if max this larger or equal to target, return I, right? And else return -1. Okay, now we pass, we fail this. The result is 1. Huh? What is this? Target is 100, fuel is 1, start fuel is 1, and what the hell? Print dp. Oh, that's way too much. Let's print dp for the one we failed. 1 and 101. Where did 101 come from? Oh, we forgot to check the distance. So when I say if dpt, right, is larger or equal to my distance, then I do it. There we go. Now we pass. Now we pass. Which means everyone shall pass. Okay, this is exactly the same as the solution, I think. Take a look here. Right? I minus -1. If it's larger, then I'm going to do this. Yeah, that's exactly the same. So this is the all-when log n solution. Okay, actually I shouldn't do it here. I have to do it here to pass it. So this one pass. This O(n squared), the O(n squared) solution. Which give us what's it? 1088. 1088 milliseconds, so 24% ranking. And I already see the other solution is heap. Alright, so that's the DP. How about the heap? Is that a little bit greedy in it? Okay, let's just read it. The amount of fuel they contain. We don't need to decide yet whether to fuel up here or not. There could be bigger gas station overhead that we'll rather fuel at. But when we run out of fuel, before reaching the next station, will retroactively fill up, greedily choosing the largest gas stations first. So we run out of fuel first, and then retroactively choosing the largest gas station first. It is guaranteed to succeed because we drive the farthest distance possible before each refilling stop, and therefore have the largest choice of gas stations to stop at. So we go the furthest, then we backtrack, right, and define the gas station with the largest amount of gas, because that's like a step. Like, what's the furthest you can go in each step? That's the same idea, that the furthest you can go in each step. But we say, for the furthest you can go in the next step, it's guaranteed to be the largest gas that's contained within the stations that can be covered. Which, if you think about it the same way, just here we do the max to compute everything, but in the other things, like we have the max of everything that has covered before. But in this solution, we are going to say we can keep a heap of the max gas, right, that we can reach. Now we just pick out the max with O log n. So this part will be log n. So how do we code it up? So for each station, right, if I have a heap, for each station, for each step, I go the longest, and then I create a heap of all the stations contained inside, and then I find a maximum, and I go to the next one, and then we go back. Right, we go back, we add the ones that we haven't added before. Right, go back to add the ones that we haven't added before. How do we know how much we need to add? Well, we just go from here, iterate through everything. Right, we iterate through everything until we cannot go anymore, and then we pop out the maximum, right, and then we go to the next one. I might be able to code this up without looking at the solution. Alright, let's try it. So this one's going to be like this. Solution 3, and we say we need a heap, right? So we have the start fuel, that's the longest it can go initially. So we're going to say the start of the heap is going to be everything that's, so we're going to say for I, that's within, right? For I, this fuel in enumerate stations, if this is smaller or equal to start fuel, right? And we're going to say this is going to be minus fuel and I, right? So this is the initial heap equals heap q dot heapify this thing, right? So that's the initial heap. Then we say, then what do we say? We say step, its current step is 0, all right? A 0 step, and then we return 0. Otherwise, we create a heap, and then we go through the heap to find the maximum, right? We go through the heap to find the maximum, right? So we say if start fuel is larger equal to target, then return 0, right? Otherwise, I'm going to say while heap. Oh, we do this one first. And then while heap, we do blah blah blah. Whenever heap is not, I'm going to return -1, right? So while heap, we're going to say the maximum, right? So max fuel and I equal to heap q dot heap pop heap, right? So the max fuel then pop out. Negative max fuel going to pop out, right? So when it pop out, then what? Then I need to know my current position. So the index. So let's say J, right? So J. So where is my J right now? Well, the furthest I can go, I have the furthest I can go. So the furthest I can go, right? So the max dis I can go is equal to start field. And then this is the I that I need to go to. So I say, what do I say? Actually, I don't even need a negative max fuel because I can get a fuel from stations. Right? I can get a fuel from stations. So this one is not necessary. This one, I can just like underscore it. So I just need an I. So that's the station I need to go to, right? And we also need to have steps equal to 0, right? Then what? Then I say I need to go to I need to go to where do I need to go to? I need to go to actually if I have is the largest I can go, right? And then the max distance is a start fuel. While heap, and then we can update the max distance, right? So every time we say if max distance is larger or equal to target, then we return steps, right? Otherwise, I say pop it out, and then so I is where I need. So I is. So otherwise, I have the max distance. I have the max distance. I have the max distance, right? And then what do we do? What do we do with the max distance? Well, what we do is with the max distance, I need to find out everything that is from the start of the heap, right, to the heap queue, heap pop, heap. This is gonna pop out the indices, the index, right? The index that is the largest one, right? With the largest amount of gas. And then, but I need to update the heap first before I do the heap pop. I need to update the heap. How do I update the heap? Exactly, how do I update the heap? Well, we update the heap by adding the stations that's currently can be covered by my max distance, right? Can be covered by the max distance. And how do I know what's the furthest that can be covered? So we need to have another one. We call it furthest index, right? We say furthest index is -1 because initially nothing gets covered, right? And then we say with a max distance, with the furthest index, right? So it can be from furthest index to the end. So I'm going to say furthest index, right? So for I in range, furthest index plus 1 till n, right, to the end, and we're going to say n is equal to len stations, right? So with this, then we can say I to furthest distance if stations I 0 the distance smaller or equal to max distance, then heap q dot heap push, right? Dot heap push. Push what? Push minus stations I 1, right? And then push maximum fuel, right? I think I just need a maximum fuel. I don't need anything else. The maximum fuel, right? Oh, we do need, so we need a maximum fuel and the I, right? So I'm gonna go through this, else break, right? If the distance is larger, then we just break. So this is to populate the heap. After populate the heap, then we know j equals this. So when we pop it out, we get the index of the stations with the largest gas, right? With the largest gas. And then what do? And then we compute the max distance again. So we compute the max distance. Okay, not only that, we have to also update furthest index going to be equal to I, right? Furthest index going to equal to I. And then from here, we're going to update, so max distance going to equal to what? Equal to the current distance, the current max distance, right? Minus stations j I, that's the fuel, right? So that's, no, that's going to be 0, the distance, minus the distance. That's the amount of fuel we're going to save. And then we're going to do the fuel. And after do the fuel, we're going to plus the distance, which means this one can be removed. So that's the new max distance, all right? After new max distance, then we go back, right? Well, heap again, then we do this. Actually, this is not going to be here. It's going to be here. Furthest plus 1 to n, and the furthest index is going to be updating. Right? So while heap, then if at any chance nothing gets pushed into the heap, which means all the stations cannot be reached, right? Then we pop it out, we get a max distance equals current max distance, and nothing changed. So we say the heap is going to be 0. Max distance is 0, right? I don't even think I need this. And then max distance steps. Where did you do steps? Here's where you do steps. We say steps plus equal to 1, right? So here's what happens. Our heap has some stuff, right? So max distance is larger, return steps. If not, then we're gonna go from I is the range. This is all the steps, all the stations, and if a station is reachable by the current max distance, we push its gas into the heap, right? And then we update the furthest index until we cannot do. The furthest index has to be updated, and then we pop the maximum among them. So these are the gas stations that I can reach, right? I can reach. What if I say I don't feel this is right? Like the maximum I can reach, right? And then I keep going. I feel like everyone that's, because if I take a gas station at position I, right, and then all the gas stations smaller than position I, they cannot be taken anymore, which means each time the heap has to be a new one. The heap has to be a new one. Yeah, otherwise I will be taking station, go to station 20 miles away, and then I take a station only 10 miles away. That doesn't make any sense. So I think the heap has to be, well, this one's going to be while true. Well, it's actually not while true. It's while furthest index is smaller in range of this furthest index. If furthest index is like if the last one, the furthest index gets to the last one, furthest index is the furthest one that I can get to with current mass distance, right? So while furthest index is smaller than will the furthest index be furthest index, keep going, plus 1, and nothing, and next one, come up, furthest index plus 1, that's good, and then furthest index plus 1, I think we can. whenever furthest index, because here we're saying furthest index, if we get everything inside, right, the furthest index, and then we get everything inside, and then we get a max out, but we still cannot reach, right? So what is the -1 condition? -1 condition is we cannot reach anybody, right? We cannot reach anybody. So if this is not, there's no heap here, or we get someone and we get a max distance, and if the furthest index will already include everybody, furthest index, right? And then we include everybody in it. And I say I'm going to take the maximum. If I can still not, that means I cannot reach, right? Which means let's keep this as true and then do the things inside. So we're going to say while furthest index is smaller than n, right? Then we're going to say if furthest index plus 1, the furthest index is the one that previously included. So plus index plus 1 is smaller than that. Then we're going to do furthest index. Let's not call it furthest index. It's too many words. Call it fi. Right? If fi furthest index plus I, 1 is smaller, then I'm going to push plus 1 and fi plus 1, right? And then fi plus equals 1. And then the next one, if smaller than, yeah, I don't feel it. Hold up. Well, if plus 1 is smaller than that, right? So this is the furthest index that is currently reachable by max distance, right? It's currently reachable. So we have a max distance. So we're going to say furthest index plus 1, and blah, 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 plus 1. And then when we break, right, when we break out, then that means we go through everything, and if there's no heap, right, so heap can go this. If we go through everything, if no heap, that means we cannot reach anything. So if not heap, then the break, right? If not heap, then it's break. That means for the current max distance, I cannot reach any of the next nodes. Otherwise, we pop this out, we get the maximum distance, we update the max distance, which can be simplified to this, and then we update the steps, and we go back up. So if this plus 1 is smaller than n, right, which means fi plus 1 is smaller or equal to n, which means if I is smaller than n. Yes, I is smaller than n, then we can do it. No, because if plus 1 is smaller than, yes, if plus 1 is smaller than n, then we can do stations, right? And then it's good. And plus 1, then if plus 1 equals to n, then we cannot do that anymore, and we break. So that means we have included everyone inside the heap. And then we do a new max distance, coming back up, and then we don't have to do this anymore because because the maximums already failed, which means what we're going to check is while, so if I, the furthest, right? The furthest, we already check the furthest. If I plus 1 is good, it's smaller than this. If not, then we don't add. And then we go for the next one. Then when we add fi plus 1, when we plus 1, then if I is equal to n minus 1, right? Then if I is n minus 1, now if I is n minus 2, then we add the next one. Now if I is n minus 1, so that's the current. Current is the largest, right? We already hit the end. If we already hit the end, and then we come back up, so we say if I is equal to n minus 1, right? That's the furthest index. Furthest index is smaller than n minus 1. Right? If furthest index has reached n minus 1, then there's no more point of going. And it, like the furthest one, all right, where is the stopping point? Right? So that's the furthest index. So we already put everything in it. And then we do a round of this. And then we come back up. No, I think this can just while true. Right? So I already do it. And here, before we hit this, if I is already equal to n minus 1, that means, right, we already added everything into it, and we still cannot, and then that we're going to break. All right, now we're going to break. Right, solution 3. Invalid syntax. Oh, fi plus 1. Heap push. Oh, I forgot a heap. Okay, we'll pass some, we'll fail some. Okay, what is the cause of this? Result 23. Max distance, steps, furthest index, length, right? We say if max distance is larger than target, then we return steps. Okay. We compute the max distance for each step. Right? At step 0, max distance start fuel. And then we're going to see the furthest index. So that's what's the furthest index? The furthest index is, in the previous round, the furthest index is covered. So for the current round, right? So fi plus equal to 1. So the current round is start from fi, right? I'm going to say if fi is equal to n, then we'll break. Then we don't have any more to give. Otherwise, we say, well, if I is smaller than n, and if station, if I, because we're already plus 1, so if I, 0 is the distance, is smaller than the max distance, we can push heap its fuel, right? Its fuel and its index into the heap. fi plus equal to 1, right? And then this one will push everything that is within the max distance into it, right? And once we finish pushing everything, we check the heap. If it's not heap, that means it's no good, because that means we cannot push anything into the heap. There's no next step, and the current max step is not good, so it's no good. Otherwise, we're gonna pop, right? In the heap pop. This is the maximum, right? This is the. And we don't need a heap. We're just looking for the maximum. We have a max distance, right? A max distance. And then we look through everything that can be pushed that is reachable by this max distance. And then we pick. Oh, the furthest is wrong. The furthest is wrong. The furthest is wrong. Hold up. I think the heap has to be here. The heap has to be here. No, the furthest is wrong. No, heap is not here. Further, fi is wrong. So, well, this is fi is smaller than n. We push it in. That's fine. And that's fine. And then here is the thing. Let's say if I is the furthest, right? The furthest, and we push the remaining into it, and then we start popping, right? We start popping. Depending on the j, right? J shall be the new fi. That's the thing, right? So how do we pop? We just stop popping, right? When we stop popping, we're going to say while heap, and then we say this, right? So if j is larger or equal to, oh, the furthest keeps going. The furthest keep going. We don't want the furthest to keep going. No. We don't want the furthest to keep going. Furthest I. So we add these into it, and we find, right? And then we find this. We find the range, right? So this is going to be the next time the start is from here. So, and we have the furthest is here, right? And then what? We have two indices, the start and the end, right? The start and the end. At the beginning, both going to be -1. And then, as we go, the end gonna expand, right? And we have end gonna expand. So we have end expand. And then, if it's within the start to end, and then we start change. The next one, so yeah, I think we have to use a start and end. Just a left and right. Left and right. -1, -1. Right. And then we say, now we're gonna we're going to try, right? And then we are going to write move forward. We try to see if we can move forward. And if we cannot move forward, then that is a problem, right? How are we going to achieve this? I'm going to say right plus equal to 1. If right is already, let's try not do this. Let's just do this. Right, while right is smaller than, and then all the if I are going to be right. All the if I is going to be right. So we're going to say is these are going to be right. If the station, this station is good, now we push it in, right plus equal to 1, do the next one. And if it fail, that's problematic. That's problematic. No, I don't like it. Let's just say plus 1, right? Plus 1 fail, then we're gonna exit. We don't do it. So this guarantees this one pointing to the last one that's within the current range. Right? If it's smaller than this, now we push it in. Right? We keep pushing, pushing, pushing. We can actually do better. I think we can do better. You just say for I in range, write I plus 1 to n, right? Say if station I, and then this is going to be or I. So this is going to be I, right? Now we keep push this, so we don't need to do this. And then at the end, we're going to break. So I will be pointing to the right, right? And we say if I is equal to right, that is not possible. I will start with ri plus 1, right? And then we try it. If it works, I plus 1. We try it. If it works, I plus 1. And we try it. And it didn't work, right? If it didn't work, I'm going to break. And we just say if I minus 1 equals this, that means nothing gets pushed in, then we're going to break. It means nothing gets pushed into the heap. So we reach the end, right? Otherwise, we're going to pop. We're going to say while heap, we pop this up. We say if j is larger than left, right? If j is larger than left, then we say max distance and we step. Max distance equals max distance plus the fuel, steps increment, and the left is equal to j, right? Equal to j. So I say, because we pop in here, so the left boundary is actually j plus 1, right? It's going to be j plus 1. Because we take j, so left boundary is going to be j plus 1. And we're going to break. We find it, now we break. If not, we just keep going. And if we go out all the heap, right? And we cannot find a j is larger than equal to the left. So like we currently have this, and everybody go out. We say else break. try it. Oh, it's still wrong. Like, it's all right. I think about it again. Two conditions. One is if nothing gets added to the heap, that is wrong. I would say while heap. What is the smart way? Look at this. I can't even code this. Why? Why I cannot code this? I have a max distance, right? I have a left-right that determines the range of gas stations that I can check, retroactively check. The previous range. And then say, anytime max distance is larger or equal to target, or return steps. That seems legit. Every time if so max distance plus this. Yeah. The max distance plus equal to stations, right? This is the taking this step. So we say steps plus 1. Then the left's gonna be j plus 1. So j is the heap popping out. So we cannot take any of the stations before j, right? So we say j is larger or equal to the letter, the left, j is larger or equal to the letter, and the left, and then we say we can take you, is it larger or equal to LE? What is LE? Okay, so here I have all these added to, and then I have case is I take whatever the j popping out, right? And then in the next round, I added more stations into it, and then I'm going to take from j from the left. Yeah, it has to be from left to a current. The current is this. And we say while heap, and then I'm going to pop the largest, and then if the largest with j is smaller, then we cannot use it. So we keep popping until we find a j that we can use, and then we break. Ri is the right range, right? And I say, so if I go from 0, this is going to be from 0 to n. I'm going to find every single one with its distance is smaller or equal to the max distance, right? If it is, I'm going to push it into the heap. It's fuel, right? And then we say, while the heap, I'm going to pop out the one with the maximum fuel, right? And then we get its index. And now we say if its index is larger or equal to the left range, then the max distance plus equals this. The max distance plus equal to the maximum fuel, right? The maximum fuel. And then we call it quits, and we increment the LE to the next one, j plus 1. Now we break this, going back up. The max distance equals, that means we take j, right? We take j, that's why steps plus equal 1. I have a new max distance. Why is this not right? All right, I don't know. When I reach a station but have negative fuel, we will add the capacity of the largest gas station we've driven by until the fuel is non-negative. If at any point this process fails, then the task is impossible. Gas stations. Target. Float infinite. For in the stations. Tank. Minus equal. What is tank? The initial tank. Location minus previous. What's previous? The previous location? So that's the amount of a tank left. If the tank is larger than 0, what do we do? If the tank is larger than 0, then heap to the heap push PQ negative capacity. Okay, so we have a tank, right? We have a tank, and to reach, so we go through each stations. I don't understand why this one doesn't work. So I have a tank. To reach each station, we will compute the current tank capacity, right? The current tank capacity. And the current tank capacity, if it's a positive value, right, for each position, if I reach there and my tank is positive, that means if the tank is positive, that means I can reach there. And I add the capacity into it, and previous equals location. So it means I reach here. And then I try to reach the next one. Right? Then I try to reach the next one. And as I reach the next one, if my tank becomes negative, right, then I need to go through the previous and current. I need to go through, so I keep driving, right? I keep driving. If at any point my tank becomes negative, then I need to go back through all the gas stations I've visited before, and then we pick the largest one, right? We pick the largest one out and to add to my tank. So that's the refilling I need to do, right? The refilling I need to do. And I check my tank. So to reach the current position, and my tank still is no good. So I keep adding the maximum from the previous until my tank is good. All right, and then if my tank is good, then I keep pushing the current one and move on. All right, and that means at each position that I reach, I compute the minimum. I have the minimum number of refilling to reach each station, right? To reach each station. And if at any station I don't have the refill, I just keep going on until I need to refill. So I just keep driving until I need to refill. I look back on all the previous gas stations and I say, okay, because I can already reach to a certain gas station, right? And it's positive. When I reach a certain gas station, I reach a gas station, and then I cannot go anymore because my tank is negative. That means somewhere, right? Somewhere in the past, I must refill. Otherwise, I just cannot reach here. And to refill, the best I can do is to refill with the maximum gas. So I get the maximum gas from the refill and to see if my tank is positive. And if my tank is positive, that means with that one refill, I can reach the current position, right? With one refill, I can reach the current position. And I keep going. So each time, if I fail, that means we need to refill another time in the past. So to think about another way, what we want to find is when we reach the target, the minimum number of refills that can get us there, right? The minimum number of refills is equivalent to what is the max amount, like what is the combination of the refill gas plus, yeah, that's a combination of what is the combination of the gas in all the gas stations can create a fuel that's larger than the distance, given that we have a constraint that at each position, at each gas station, we have to have, when we reach a certain gas station, we have to have larger than or equal to 0 on the tank. So therefore, we try to go through every single gas station, right? We go through every single gas station. Why do we go through every single gas station? Why can't we just say we have the longest, right? We have the largest. And then it's the largest distance, right? We can go. And then we have a negative. So we need to find the gas station that can support us to become positive. And then we go to the next one. We go just keep extending our distance, right? And then that means in this solution we don't have to have the left and right. We do have to have right, but we don't have to have left, because we can just pick any one. Right? It's not like we pick this one and then we're gonna start from this station and then going to, yeah, we do start from this station and going to the maximum, right? But we can do, we don't have to go, like this one doesn't really mean anything. It doesn't mean anything. We just pick out the heap, right? And then that's our next max, right? So think about this is with the max distance. We want the max distance to reach the target, right? So with the max distance, we put everything that we can put into the heap. right? And then after we do that, we pick out the largest one, and then we try to extend the max distance. And after that, we try to see if there's anything more we can put into it. And we can even say there's nothing more we can put into it. And we just dig into the heap. We'll put another one, and then we keep going until either we reach it or we we exhaust something. We exhaust for each step of the max, right? We have the max, and then we say if the current station can do it, then we include it in the max. Yeah, we can pick other things as well. I put this one in, and then we record where I am at, and then the next one come up, we add these, so record where I am at, and then push them into the heap, and then eventually, I think the check is on the heap, right? If the heap is empty, that means we have, okay, so there's no left. We don't have to do left, it's just the right, right? And then, this doesn't really matter. Like, we can just do while plus 1 is smaller than n, and then we say I plus 1, awesome, is smaller or equal to max distance, right? Station, hold on, yes, that's right. If this one is smaller than max distance, now we push this one in, right? And then we say an Ri plus equal to 1, right? We'll just keep going until we say we cannot. Now we break it. Don't need to check, right? So Ri always Ri plus 1, right? Ri plus equal to 1, and then we check the next one, and it's larger than that's it. So that's it. So Ri always pointing to the current edge, right? The current edge. Now we're gonna do the heap. We just say if heap, right? We're gonna do this, and we do the max distance, right? The max distance is gonna be extended by adding this, and then we do this. And else, if there's no heap, then we're gonna break, right? So max distance extended. And then go back again. Max distance is not, then we try this, and then if this one is the station still not, then we can add another one. Let's try this. Now we fail on 2 of them. Why is this one not working? Plus, we don't need J, so we can just push. We can just push this. Oh, because this is Ri plus 1. No, we don't need this. We just need to push this one, and then here, there's no J, so we can just pop it. Say minus equal to this. There we go. Finally, I think this one works. Looks terrible, looks awful, but I think it's gonna work. Alright, let's make steps is 0, Ri is the index of the rightmost, right? The rightmost station that we can reach. We can currently reach. Right. And did you even use and? Yes, we do. We use and. I always put a land station. So I don't want to have another one because it's only the single place that exists. Heap is this, and then we say while this. I can do here while this and, right? And this, we do this. Then we break it out. And then we say if heap, else we do this, right? And if max distance is larger than target, then we return steps. Okay, this is the heap solution from the official solution. The logic is the same, but the implementation is different. This one is more. This one follows exactly the logic described. We find the max distance. We find the max distance, right? We find the max distance. If it is not reaching the target, right? We
back with the mom.
We go through all the stations that lie within max distance and push their fuel to a heap. We need to use Ri to keep track of which station to use I to signify the rightmost station that has been added into the heap in the previous round. This makes sure that each station is only pushed into the heap once. Then we pop, right? Then we pop the station with the max fuel and update max distance and steps. We repeat this procedure until target is reached or heap is empty. Now we can actually do while heap, and I'm going to put a 0 in here, right? Oh, 0, is that considered? Yeah, that's not considered smallest, right? So if heap, yeah, we don't need to do this. I think we'll still pass. So the place that I got stuck. Yeah, I can have other things. The place that I got stuck was that I thought the only station one can use must fall in I thought, right, with that I thought if I have used stations I, then I cannot use stations I minus 1. However, this is not true because we do not care about the order of stations while popping from the heap. We are just saying that to reach the current max distance, we need stations I and I minus 1. Their order doesn't matter. The solutions implementation is also interesting. Yeah, it's also interesting. But I am too tired to implement it again. All right, let's try. Unless this one fail, right? If this one fail, then we are forced to do the solution one. I mean, if you think about the length, what's 23 to 30, that's 13 lines, right? It's about the same, right? It's about the same, so it doesn't really matter. Yeah, it's 116 milliseconds. So this one is Owen login 0.16 milliseconds, 89% ranking. Yeah, very good. All right, that's it. I'm very, very tired. 3 hours and 42 minutes. It's always like that. It's always like that. I don't have any more energy to go through this, so I think I'll just call it. Oh, I have to read. And more fuel in the tank. Wow. This one's a nightmare. This is a backtrack problem. I hate this, like you just post a solution. Yeah, I think the DP1 shall be able to figure out. Right? DP1 shall be able to figure out. The fuel, right? DPI is the max distance we can go with how many with a number of steps, right? And the number of steps. So if I'm at a current gas station, right, and I look at the DP table, and I say from DPI, this is like a T is going to be I, right? Because I am the current I'm actually so I plus one number of stations. So the previous most number of stations is DPI. So from DPT, I just say like if from DPT, see if I can reach me, right? if dpt the largest distance I can reach me, then I know from the dpt plus 1, right? So now we'll include me, right? Include me. Yeah, just include me at each number of stations. If I include me, then if it's 1 station, 2 station, or all the way to I plus 1 station. So I need to know 0 station, 1 station to I station, what is the maximum that you can reach. Then include me, then I'll get a, a, a new maximum distance I can go to, right? And then we have to go from t all the way down because I don't want double counting. All right, that's it. That's it for today. It's a long effort. Yeah, every Saturday. Every Saturday. All right, see you guys tomorrow. Adios.